A very good morning to one and all. Last class we have seen what exactly maximum power transfer means, and we have done a few problems. But today, again, we'll continue with that. We'll just quickly look at an example. Or basically, maximum power transfer theorem tells us that if there's a source, right? If there's a source and which have an internal resistance Ri, let's say, then the load is RL. In such a case, we have maximum power transfer to be equal to, which is actually equal to I square R, can be transferred to the load only if the internal resistance is equal to the load resistance RL. This is a case where we have seen, and with it, we have also understood that we have to actually find out the resistance and compare it to load. So we'll quickly look at one problem where we have to do such a where such a scenario is presented. Now, well, let's see a problem here. You're given a circuit which looks something like this, right? And this circuit, you have resistances, and sorry about that. We have also a resistance here, and let's call this AB, and here we have the load RL. This load is changeable, so it can be variable, so it's given by an arrow RL. So let us quickly look at that. 2 ohms, 1 ohms, 4 ohms, 1 ohm here again, 2 ohm, and the source is 8 volt. Now the question is, we have to calculate the value of RL. What is the value of RL so that maximum value will be transferred? What is the value of RL so that maximum value will be transferred? So that is the question here. Now, to solve such a question, we'll quickly look at one theorem which we have already done before, and that is Thevenin's theorem. Now, why do this? Because it can simplify circuit, right? Now, this circuit has a series of resistances connected here. Now, these resistances can be simplified using Thevenin's, right? So, for Thevenin's, we need to find out VTH and RTH. So, first, what is I? Let's see what is I. I is nothing but if we open the circuit, so for VTH, for RTH, we need to find out VTH. We open the load, right? So my circuit looks something like this. And from here we know that circuit will not flow in loop B, current will not flow in loop B, so whatever current flows in the first loop. So this is 2 ohms, this is 4 ohms, and this is another 2 ohms and 8 volts, right? 8 volts. So with this, what will happen is we need to find out what is VTH. So what is VTH is, VTH is nothing but VAB, right? And this is equal to nothing but, if I have here VPQ, it's again VPQ. That we have seen, right? It's an open circuit. Voltage are seen from the load. Now, once we do that, we find out the current I. So I here will be equal to 8 volts, right? Divided by 2 ohms plus 4 ohms plus 2 ohms, which is nothing but 1 ampere. And then my VTH will be nothing but the voltage drop across 4 ohms, so it will be I into 4 ohms, which is equal to 4 volts. So this is my VTH. Next, RTH. What is RTH? Now, if you if you have to find out RTH, I'll just quickly give space here. RTH is nothing but the same one, the same figure, but now the source is shorted, right? We have to short the source. So this is gonna look something like this. So this is AB. So we start from here. We start from this point. So what is this resistance? 1 ohm. This is 4 ohms. This is 2 ohms. This is also 2 ohms. This is also 1 ohm. So we start from here. We start from point A. So we start from point A. So A, we encounter a resistance 1 ohm, right? And then if you move here, there is a parallel path. So there's a parallel path. I'll break it into parallel path, 2 ohms. This side is 4 ohms, right? So 2 ohms is here. This is 4 ohms. We have to move like this, right? You have to move like this, and then we see there's a part here. So I'm breaking that part. This is the breakage that I've broken because of that particular parallel part out there, right? And then this moves on, right? And meets these two resistance, this 2 ohm resistance. So basically this is another 2 ohm resistance here, and again it meets the 4 ohm branch here. So let us connect it together, and finally from this point it goes to 1 ohm. So from this point it goes to 1 ohm, right? So that is AB. So this is my resistance, and if you calculate it, this is 1 ohm, also 1 ohm. So it'll be 2 parallel 2, 2 series 2, so 4 parallel 4. So it's something look like this, and something look like this, right? This is 1 ohm, this is another 1 ohm resistance, 1 ohm, 1 ohm, 4 ohms, 4 ohms, and then what we'll see is one total resistance RTH is nothing but 1 in series with 4 parallel 4 in series with 1 ohm. So this is 1 plus 4 parallel 4 is 4 into 4 divided by 4, which is nothing but 16 divided by 8, which is 2 plus 1. So this is my resistance 4 ohms. That is my RTH 4 ohms. And with this, what we see is that for maximum power transfer, you have to have RTH for maximum power transfer, for maximum power transfer, you have to have RTH equal to RI. So basically your power, which is maximum power, Pmax, is nothing but E square by 4RL, E square by 4RL, right? Which is nothing but VTH, right? Open circuit square by 4RL, which is equal to 4 into 4 divided by 4 into 4 to 1 over, right? So this is your maximum power transfer. So this is your calculation. So this, if you didn't understand any portion out here, kindly let me know. So basically this is nothing but power, which is V square by R, right? V square by R. So this is what you get there. Okay, that is one circuit, right? We can solve another circuit, right? And we can see that such a thing always happen whenever there's maximum power transfer. You always have Ri equal to Rl. So that is how we solve these questions, and we can quickly draw another circuit here, a bit complex circuit, right? We can quickly take this circuit here, 24 ohms, and then 6 ohms here, 6 ohms, 6 ohm. Then we have RL over here, it's RL, and this is 3 ohms, and finally we have 6 amperes here, 6 amperes. Now if you remember clearly, I've taught you, this is 24 volts, I've taught you how to convert a current source to voltage source and a voltage source to current source right? We'll do that. So first of all, we'll convert this current source to voltage source. So this is 24. So this is looks something like this. So this is now my 24 volt source. My 6 ohm. This is my 6 ohms, right? This is my RL. Now this 3 ohms and this 6 volts. So you have to multiply 6 into 3. 3 is 18. So this changes to 18. So that is how simple it is to convert a voltage source. This is 6 is 18, right? 18 volts, and this is 3 ohms. So you take this parallel resistance, you multiply with the current source, 6 is 18, and then you bring back that parallel source, a parallel resistance in series with the 18 volt source. That gives you a voltage source. So that is what we have. Now we have to calculate. We can calculate what is VTH from here, right? So for VTH, we need to find out what is the we have to remove the load. So we let us remove the load for VTH. Let's remove the load. We remove the load here. We remove the load, right? And then this also is not there anymore. And then the load is removed. Let's call it AB. Let's remove, and then we have 3 ohms, and we have 18 volts, right? 18, 24 volts, 18 volts. Then we have 3 ohms, 6 ohms, 6 ohms. Now, if you use KVL here to find out VTH, for VTH, okay, this is for VTH. So we use KVL for doing that. Basically, all these problems will be, we can combine one or two laws and theorems together to give us a more easier way out. So if you look at here, this is difficult to find a VTH here, right? So previously we have done such problems also while doing VTH or while doing Thevenin's theorem. So we're going for the same approach. So let's start from here. 24. If I is the current flowing through it, I 24 minus 6I, right? Minus 3I minus 18, because this is series opposing, minus 6I becomes equal to 0. You get 6 is equal to 559, and finally you get I to be equal to 2 by 5, which is approximately 0.4 amperes. Now what is VTH? VTH is nothing but VAB. VTH is nothing but VAB, which is equal to 18 plus 3I, right? 18 plus 3 into I. This is nothing but 18 plus 3 into 0.4 is equal to 18 plus 1.2, which is equal to 19.2 volts. Now, what is R? That is VTH. What is RTH? For RTH, if you take the same thing, you short the source. So this is A, this is point B. As seen from the load end, so what we have to do is what we're gonna see we're gonna see 6 and 6 in series and 3 in parallel, right? So basically this is something like this, right? Something like this. So 6 in series and 3 in parallel. So what do you have? 6, 6 and 3. So 6 divided by 6 divided by 12. This gives you 3. 3 plus 3. This is in series, right? So 12 parallel 3. Are we clear? 12 parallel 3, right? So this is nothing but 12 parallel 3. So you'll have RTH to be equal to 6 plus 6 parallel 3. That will give you 12 parallel 3. So 12 into 3 by 12 plus 3 is equal to 36 by 15. So approximately equal to 5 3 is 15. 3 5 is 15. 3 12 is 5 2 is 10.4 ohms, right? So that is your RTH. Now for maximum power transfer, we have RTH is equal to RL is equal to RI. So that will be equal approximately to 2.4 ohms. So what is E? E is nothing but E divided by, sorry about that. What is I? So 2.4 ohms. So what is I? I is nothing but E divided by I plus RL, which is nothing but 19.2 divided by this 19.2 divided by 2.4 plus 2.4 should give you approximately 4 amperes. So what's maximum power transfer? So Pmax is equal to I square R. So I square is 4, where RL is 2.4. It will give you 38.4 watts. Right? Now, for that, you can easily show that the efficiency eta is nothing but equal to 50%, right? For this one. Similarly, that's the same way we showed earlier in an earlier session. So this is maximum power transfer for you, and we have seen what exactly happens, right? We have also seen that in if a complex impedance circuit, we have a similar situation. If we have a similar situation, then the resistance should be equal to the complex conjugate, right, for a complex circuit. So that is all for maximum power transfer. So next class we'll look at reciprocity theorem, and with that we will also come towards the last section, which is your noodle analysis. So we'll quickly have the statement of a reciprocity theorem now before we go over to that problem next. So let's just quickly look at reciprocity theorem. What is reciprocity theorem? Reciprocity theorem. Reciprocity theorem. What does it say? Now, it says that in a linear bilateral network, in a linear bilateral network, in a linear bilateral network, right? If a voltage source, if a voltage source in a branch A, produces a current, I in any branch B, then if the same voltage source, is removed and inserted in branch B, is removed and inserted in branch B, it will produce a current I in branch A. It will produce a current I in branch A. In other words, we can say that V and I are interchangeable between branch A and branch B. So in other words, we can say that V and I are interchangeable between branch A and branch A and B. So we'll quickly look at it. What exactly do you mean by that, right? So if I have uh, let's say if I have a problem given by this, so this is network, let's say this is a network, right, a circuit for that matter. If I have this circuit, that's not right order values. So if I and if current I flows through this branch and voltage is here, so basically I can do the other way around, and this in the sense that I can have, so let me just write the value so that it be clear, right? 2 ohms, 3 ohms, 4 ohms, 6 ohms, and this also 2 ohms. So if I do that, if I have I here and V there, I can interchange it. I can have, if I find out what is the current here through 6 ohms, what's the current here, I through 2 ohms, sorry, through this branch AB, that's called CD. It's called CD here, that's called AB there, right? So if I have such a circuit, then I can interchange V and I. So basically what happens if I do that, so this happens, right? I can give something like this. I can have something like that, right? I can have something like that. So it will not change anything. It will not change. So basically this 24 volts is here now. I is there, voltage is here, and I is there, and both will be having, I suppose I is equal to 5 amperes here. You will also get I is equal to 5 amperes over there. So that is reciprocity theorem. We'll look at a few examples and calculate, and then we will wind up. So basically this particular theorem, we'll just look at one example and then move on to analysis. So we'll stop here for today. Thank you all.